Hello, Introstat students. Today we're going to do, for this video, we're going to do another exercise. And we are now focusing, we did what is a sampling distribution and did exercise on bias and unbiased estimator on the previous video. So for this video, we are looking at the lesson on sampling distribution of a sample proportion. Okay? And the exercise that we need to focus on is the normal condition for a sample proportion. So if I click on that, and in fact, I'm going to click my picture away. Don't really like to see that. So, all right, let's look at this. So a map website claims to be available 99.995% of the time, measured in minute-long increments. Suppose that we took a random sample of n equals to 1,000 minutes. So there's a sample size. So every minute, right? You do it's increment of 1 minute, and now you're looking at 1,000 of them, right? Sample size of 1,000 from the population of minutes in a year. It's a lot of minutes in a year, so 1,000 should be okay. And computed the proportion of minutes in each sample for which the website was available. We can assume the website's claim is accurate. And so what will be the shape of the sampling distribution of the proportion of minutes in which this website is available? So to look at the shape, now there are a few shapes you can imagine. It could be skewed right? This is skewed right, whether there's less here on the right hand side, that means the people here on the right hand side is screwed. That's why it's skewed right. Then there is also skewed left, right? Skewed left, where there's less on the left hand side. The people on the left hand side is screwed. It's skewed left. And there is such a thing called normal, where it's symmetric, bell shape, single peak. Okay, those are the common ones. So they're asking you what's the shape. It could be any of those three. Now, to check for the shape, they are basically asking you, right? Is it skewed to the left, right here, skewed to the left? Is it skewed to the right here? Or is it approximately normal? All right, approximately normal. And there's a way to check. And we check by doing n times p, right? Is that greater or equals to 10? And then do n times 1 minus p. Is that greater or equals to 10? You have to do those two, right? You have to do those two. If the conditions are satisfied, if when you take n times p, if it's greater than 10, or take n times 1 minus p, if it's also greater or equals to 10, then you can say that the shape of the sampling distribution is approximately normal, right? It's approximately normal. So what is my n here? N here is 1,000. And what is my p? My p here, this is the claim. The website claims to be available 99.995% of the time. So if you change that to decimal, it will be 0.99995. Okay? All right, now take n times p. If you take n times p, which is 1,000 times 0.99995, and all you have to do is take this decimal is 1, 2, 3, because there are 3 zeros. You just go 3 to the right, and the answer is 999.95, and that is indeed greater than 10. How about n times 1 minus p? So you're taking 1,000 times it by 1 minus 0.99995. And that is, so 1,000, right, times 1 minus point, so it's 0 0.000 05. Yep, 1, 2, 3, 4, 5. Okay, so if you do that, and if we round this, so not round, but times it by 1,000, we move 1, 2, 3, 3 zeros, because there are three decimal to the right, and because there are 3 zeros here, and the answer here is 0.05, which is less than 10, right? Which is less than 10. So now we know it's either skewed to the left and skewed to the right. Now, which one is it? Which one is it? So which one is it depends on which value is less and which value is more. So if you look at this, n times p, right? N times p is 999.95, and n times 1 minus p is 0.05. So n times p, you can view it as like a success, right? Success, which is kind of, success or failure. So in this case, n times 1 minus p, which is kind of like the failure, right? It did not meet the proportion of minutes, and it's 0.05. So it's less to the left, more to the right. So here will be skewed to the right, right? Skewed to the, oh no, skewed to the left. So here we have a left skewed sampling distribution because population proportion is so extreme relative to the sample size that are fewer than 10 accepted failure per sample, right? Remember here? So here, when we did the n times 1 minus p, so that's kind of viewed as a failure, and that was very, very small. If it's very, very small, that means you tend to have less in front and then more on the right. That's why it's skewed to the left. Okay? Every time when you have more success than failure is skewed left. If you have more failure than success is skewed right. Right? So let's go on. So Tony runs a restaurant that receives a shipment of 200 oranges every day. According to the supplier, approximately 11% of the population of these oranges is overripe. Suppose that Tony calculates the daily proportion of overripe oranges in her sample of 200. We can assume the supplier's claim is true and that the oranges each day represent a random sample. So here, they ask you again, what's the shape of the sampling distribution? And here, you're asking, what is it? Skew left, skew right? Normally, is it normal or approximately normal or uniform? Now, uniform looks like this. Uniform looks like this. It's like one straight line, right? So it's, however you look at it, it's the same everywhere if you go on the x-axis. That's what a uniform distribution looks like. So what's my n? My n is 200. And what is my p? My p is the probability of success, which is, right, here, well, success is a bad thing because it's overripe. So, but it's still 0.11. So if we take n times p, we take 200 times it by 0.11, and 0.11 times 200, that should give us 22. Woohoo! 22 success, and that is where it goes to 10. Then look at n is times 1 minus p. So it will be 200 times 1 minus 0.11, and that is 1 minus 0.11 0.11 is 0.89. Okay, so 200 times 0.89, and that is a big number, right? That is about 178, and that is also greater than or equals to 10. So when both conditions are satisfied, n times p greater or equals to 10, n times 1 minus p greater or equals to 10, it is approximately the sampling distribution. The shape of the sampling distribution is approximately normal. Okay, let's go on. A quality control inspector routinely takes random sample of 200 cans of fruit cocktail produced in the packing plant and calculates the proportion p hat. So, ladies and gentlemen, new symbol here. If you see this p hat, right, p with a hat on it, we call it p hat. That is sample proportion, right? P hat, it means sample proportion. Please remember that. So sample proportion of cans from each sample with at least 3 cherries. So, okay. Suppose that 98% of fruit cocktail produced in that packing plant contains at least 3 cherries. So that's what their claim is. So which of the following distribution is the best approximation of the sampling distribution of the sample proportion? So same idea. So N is 200, right? Sample is 200. The P, right, is the probability of fruit cocktail that produced in that packing plant that contains at least 3 cherries is 0.98. So let's do an N times P. So 200 times 0.98. Now, this is the amount of success, which is going to be huge. 0.98 times 200. Okay, so 196. And that is definitely greater or equals to 10. How about n times 1 minus p? And so you're taking 200 times 1 minus 0.98. So 1 minus 0.98, 98 is 0.02. So you're looking at 200 times 0.02, right? 200 times 0.02. Put the equal signs here. Times it by 200. It's 4. That is less than or equals to 10. So the failure here is 4, which is so much less than 196 for the success, which is on the right-hand side. So you have less on the left. So you are looking at if you're looking at it, could be skewed left, right? It could be skewed left. Okay. All right, let's do one more. A band selects 40 ticket holders at random from each concert to win t-shirts. Woohoo! A band knows that 55% of the ticket holders buy their tickets at least a month before the concert. Suppose the band calculated the proportion p hat, which is the sample proportion, right, of winners from each concert who bought their tickets at least a month before the concert. So it calculates, right? Calculates. Suppose the band calculated the proportion p hat of winners. So which of the following distribution is the best approximation of the sampling distribution of the sample proportion of winners from each concert who bought their tickets at least a month before the concert? So same idea, right? They want to see, so you're looking at the sampling distribution of the sample proportion. I need the N, and here is 40, right? 40 ticket holders, and then the P, which is 0.55, because 55% of the ticket holders buy their tickets at least a month before the concert. So N times P, taking 40 times 0.55, 0.55 times 40, and that is 22. Woohoo! Greater equals to 10. And then let's take N times 1 minus P, which is 40 times 1 minus 0.55, and that is 40 times 0.45. All right, so 0.45 times 200, 90. Woohoo! So both N times P greater equals to 10, N times 1 minus P greater equals to 10. we can safely say that the sampling distribution is approximately normal. Right here. Normal is the bell shape, right? Bell shape, single peak. Okay, so if you have any questions, let me know. I'll post this on Canvas. Thank you very much.